we had a question on 2374, which says that we have a compound C9H10, some spectroscopy is shown for that compound. It dimerizes in the presence of acid to create this product. So the first thing that I usually ask myself when I'm given a formula is, how many units of unsaturation do I have? Normally, if we had a fully saturated product, we'd have C9 and then H 2 times that 9 plus 2 more, so H20. Since we actually only have H10, we'd subtract that and divide by 2 for 5 units of unsaturation. If I'm trying to figure out what this monomer is, I think there's a pretty good chance that we have a benzene in it, since we see that part of the structure show up in both of these cases. So I'm going to start out with that benzene. The benzene has one ring and 3 double bonds, so it has 4 units of unsaturation. We also have 3 additional carbons. One of those has to be a double bond or a ring, probably a double bond. We can put 1 carbon off, but we can't have any sort of unsaturation on this carbon because it'd create too many bonds to this carbon. So we have to have another bond coming off before we have any unsaturation. That gives us 8 of our 9 carbons, and then the question is, do we put it over here, or over here? Hopefully we can see that there are a couple of places where we have these isopropyl type groups, right, like this, or like this. And so we might be able to see that we might start out from a product like this. When we're trying to think about what actually happens in this reaction mechanism, we want to think about what's actually going to happen first with the acid. The acid is going to activate this group right here. This is going to be our highest energy set of electrons. And so the very first thing that's going to happen is we're going to react this and pick up an H+. That gives us a product that looks like this. This is a relatively stable carbocation because this positive charge can be delocalized throughout the ring, and it's already tertiary to begin with. So it's both tertiary and resonance stabilized. When we want to react this, we can go through one of 2 types of reactions. One is we could have this be a group that adds on to another aromatic ring, or we could have this be a group that adds on to another alkene. Another alkene is going to be generally higher in energy for its electrons, so it's going to be a more likely recipient for those electrons. So I'm going to draw the same alkene over again. These electrons then can add up to here. We can form a new bond between this carbon and this carbon. I'm going to redraw that product down here. So we have that same isopropyl group that was up there before, but now we have a ring, a new bond that's going to go to this